Okay, this is the first class, the real numbers. It's not a mathematics class, it is a physics class, more or less scientific class. Okay, however, everybody in this class is more familiar with the mathematics rather than physics, and physics has a very much overlap with mathematics. So let me focus on mathematical feature of nature at the starting point. What is the set n? You're familiar with the n. It comes from natural number. Natural number is an integer, positive integer, 1, 2, 3, 4. We learn the natural number from elementary school. All of the natural numbers are multiple of 1. Perhaps in the previous class, I told you the number in physics is different from the number in mathematics. So mathematical number is a subset of numbers we treat in physics. And wait a second. If you have some time, I ask you to visit this general physics website and then see here the ESA. We are working on C series, and the series A contains the A1 numbers in physics differ from those in mathematics. So if you have some time, so you can review this part to enhance your understanding. Okay. So if you have some number in physics, this one is not always a pure number. Usually one is a multiple of number 1 times physical unit. Because any variable, for example, m, is a number. However, in physics, this italic letter represents a physical quantity. Any physical quantity has its own physical dimensions. So that's a different feature in comparison with a mathematical number. For example, we have a height or length that has the physical unit of length. And we multiply some number on that physical unit to represent the exact amount of length. Something like that. Anyway, if you have some number, you want to make an operation, simplest operation, construct algebraic property of a set of numbers. Algebra consists of addition, subtraction, multiplication, and its inverse division. So everybody knows very well about it. Anyway, just like what I have told you just a minute ago, physical quantity has always a physical dimensions. This dimension is different from mathematical dimension. You know, the number line represents a one-dimensional space. So if you choose the origin and 1, and then you can make a one-to-one mapping from the real numbers to a real space. Okay, this is one dimension. If you draw two axes, one is x and the other is called y, they are perpendicular to each other, you will find a two-dimensional plane. Usually the two-dimensional plane can be expressed as a ordered number. This one represents the x coordinate, and this one represents the y coordinate. So in this case, a point on a plane, and many points, every point on a plane can be treated as a two-dimensional object in mathematical sense. And if you bring in another axis that is perpendicular to both x and y axis, that is called the z-axis, you can represent any point in the three-dimensional space. These dimension 1, 2, and 3 are mathematical dimensions. And in physics, we have this mathematical dimension as well as the physical dimensions. And any physical quantity and has its own dimensions, and its dimensions are expressed as a product of powers of mass, length, and time. Remember. So we require some unit to represent the physical quantity. Let's solve a simple problem. Operation, which operation is correct? In mathematics, 1 plus 0 is 1. Everybody knows it. However, 1 centimeter plus 1 kilometer. Okay, this is a length, this is a length. Okay, 0 kilometer is the same as 0 meter, the same as 0 centimeter. The scale is, after being multiplied by 0, you have lost the scale. However, still you have a physical dimensions. So it's finally you will find the answer is 1 centimeter. B, we have 1 centimeter. We want to add 1 centimeter and 0 kilogram. Haha. It's a problem. We have a physical dimensions of length on the first term. However, the second term has the physical dimensions of mass, and you cannot add mass and length. Okay, this physical dimension discrepancy will lead we cannot define the sum, so it is wrong. 1 meter per second squared, it is length divided by time squared, but length over time, so these two also have discrepancy in the physical dimension, not defined. In a similar manner, time and mass cannot be added. So this is the answer. And usually we make, in everyday life, we make many such mistakes. Number 3, what are the commutative law, associative law, and distributive law of algebra? You are familiar with these from perhaps elementary school, middle school, or high school. We have a mapping of the two elements that is mapped to another element of the set of numbers is called the operation. And some operation is commutative and some operation is not. For example, 1 divided by 2 and 2 divided by 1, they are different. So division is not commutative. However, the addition is always commutative. Multiplication is also commutative. However, matrix multiplication is not commutative. Something like that. So if it is commutative, that means If you exchange the order of operation, you will find exactly the same result. Associative law, if you have a similar operation in series, sometimes it depends on the order of operation. I mean, we have these three pieces to be summed. We can try this sum first and then make a next sum. And we can do this job in different order. Fortunately, these two numbers were found to be the same. How can we find this kind of rule? Can you give me any answer? It is based on the experience from our life. Okay, so mathematicians generalized those of our experience to make an abstract logical system. So we studied associative law, and we have addition and multiplication. Repeated addition is expressed as a multiplication. For example, 1 plus 1 plus 1, I don't want to repeat. It's very tedious. Let me write it. Adding 1 by 3 times. 1 times is 3. So multiplication is a kind of shorthand of repeated addition. Okay, so what happens if I have the addition of two numbers consisting of a product? So if we have a common factor, I can factorize this. So this distributive law is very important for simplifying our expression, complicated expression in a factored form. Okay. Let's see. This is a center of mass of the two-body system. Center of mass, it is not a difficult concept. Just forget about the center of mass, but you can expect this one is your record of English, your record of mathematics, or anything else. And finally, you find your own average value of your record. Depending on the subject, the total will be different. So that is a weighted average over the subjects. However, there is a weighting factor, how much important. So center of mass is nothing but the weighted average of a position of a particles weighted by the mass, relative mass. Why? I can rewrite this one as m1 over m1 plus m2 multiplied by x1, m2 over m1 plus m2 multiplied by x2. I can see these coefficients. What's that? If I sum them up, it is trivial. What's that? This is 1. Aha. It is a kind of weight. Weight means a kind of probability. Sum of all probability becomes 1, something like that. So this Cm, that means the center of mass, is the weighted average of the position of the particles. For example, we have a sun and we have Earth, a very tiny object. Where is the center of mass of this two-body system? Actually, it is infinite, and its mass is, for example, 1 gram and is 1 ton, something like that. Where is the center of mass? You can make a weighted average. It is negligible, and the center of mass should be near the center of the sun, something like that. In the computation of center of mass, let's forget about everything and return to the dimensions. This one has a dimension of length, and this one, dimensions of mass. However, numerator has a mass and length. In the denominator, we have mass. So as far as the dimensions are concerned, two masses cancel exactly, and your final result has the dimensions of length. Okay, that's the reason why I use the capital letter. Capital letter represents it represents the total system of two-body system, but use the still x. That's x means it is related to the length scale. Okay. As I already told you, this rho is a weight of each particle. Let's see, weight. Weight is actually force applied to a massive body by the gravitation. This is talking to you. Our actual every word we are using, everybody, hides the physical nature of objects. Okay. Mathematically, it is a kind of probability of something like that, but its origin, this mathematics origin, is what? Physics, nature. Okay, remember. Okay, just like this, when we study this C lecture, I will introduce the solution for the problems that will appear in the beta quiz. But beta quiz will not be in this form. You do not have to fill the answer sheet, but you can choose what's correct, what's wrong. So if you have that kind of elementary ability, you can still survive. Consider three particles, A, B, and C, and A, B, C, okay, they are all on the x-axis. Okay, we have A, we have B, and we have C. We can express the position of C in units of the displacement from A to B. Okay. First of all, let's see. These two are of the same dimension, so XA and XB can be either added or subtracted. That's fine. And there is XA also. These two can be added only if they are of the same physical dimensions. Because this and this are all, both of them are of physical length dimensions, this T must be a dimensionless parameter. This is a pure mathematical number. Okay. Usually, we say this is the unit. Sometimes you can use this unit as a centimeter. Sometimes you can use a meter, kilometer, or if you want to consider a galaxy that is very far away from Earth, then you can use the length as a light year, something like that. Okay, which statement is false? The physical dimensions of T, right now this T is not time, but a single parameter, the same as those of XA. Stupid. No, not at all. This is a pure number. T is a pure number with the physical dimensions, pure number that must not carry any power on top of mass, length, and time. Okay, dimensionless. Okay. T, okay, we can make an algebra, subtract both sides by x sub a, then we can find this one on the left-hand side. And if I want to find the value of t, we can divide both sides by the length xb minus xa. So this is a way to find the value of t. xb and xc minus xa are of the same physical dimension. Correct. Okay, what is the additive identity of natural number n? Additive identity. Identity means no effect. If I make an operation and the result of operation doesn't change anything, in that case we say it is identity. In the case of addition, additive identity is a zero. Everybody in this classroom must know about that. And because the sum is commutative, so I can reorder this a plus 0 or 0 plus a, and both of them must be uniquely defined, and it is equal to a. So this operation doesn't change anything. Once I know the identity, we are interested in the operation cancellation. That means I'd like to revoke the previous calculation operation. That means if I cancel it, the result must be the same as before. That means I need to find the inverse. So that appears on the next page. But let us consider a subtle but very stupid example. So everybody knows that 0 is uniquely defined. However, somebody can raise an issue. Oh, there should be x prime that gives the same result after the operation, but he claims that his 0 prime is different from 0. Let's see if he's making any mistake or not. So just let us follow his claim that x prime and the 0 prime is another additive identity that is different from the original one that is called the 0. Let's see. So if 0 prime is an additive identity, I can add this one to what I know. And the result should be the same as before. But because the addition is commutative, I can exchange the order and I apply the same rule that I learned before. 0 doesn't change anything after addition, so this one should be the same. However, I knew that the sum of any two numbers is uniquely defined. That is the result of the commutative law. And actually that commutative law was known by our own experience. If you can find a counterexample, then commutative law may be wrong. But nobody has found it yet. So as a result, because these two are the same, because of the commutative law, the 0 and 0 prime, they should be the same. It is a contradiction. So his claim that they are different is wrong. This kind of way of a very stupid way of proving a proposition is called reduction to absurdity. So it is very close to our spirit that escape from scientific absurdity. Even Newton, Einstein, very famous people were ignorant of the truth, and they were, not us. I'm not talking about you and me. Even those famous persons were very absurd in the beginning. However, they were clever enough to find the solution, just like what we have done in the weekend, to break the class into two pieces, and we have achieved our object. Okay, reduction to absurdity. Because a zero is uniquely defined, we can make use of this logic that to identify whether two numbers are the same or not by subtraction. Easy way is to subtract two numbers and you find the answer. This is a zero. Because zero is unique, you can claim that the two numbers are uniquely defined. That means two numbers are the same. They are not different at all.